Okay, so in this problem, this sequence is given that g of r is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by r. And they are saying that summation r is varying from 1 to n, 2r plus 1 into g of r is p of n into g of n plus 1 minus qn. Okay, where pn and gn are polynomial function of n. So we have to evaluate this. So basically we have to find pn and qn, then we can evaluate these. Okay. Now, if we write this summation, that we can clearly see that this summation we can write. If we put r equal to 1, what we are getting? For r equal to 1, this is 3 into g of 1, and g of 1 is 1 only. Okay. So for r equal to 2, this term will be 5. So 5 into g of 2, g of 2 is simply 5 times of g of 2 is 1 plus 1 by 2, right? So if we write this sequence, what we are getting? We are getting 3 times of 1 plus, for r value 2, we are getting 5 times of 1 plus 1 by 2. Then if we put r value 3, for r value 3, we are going to get, this will become 3 into 2, 6 plus 1, 7. 7 into g of 3 will be 1 plus 1 by 2 plus 1 by 3, because we are putting r value 3. So this summation will go till 3. So 1 plus 1 by 2 plus 1 by 3. Correct? So this is, we are getting 1 plus 1 by 2 plus 1 by 3. That r is varying from 1 to n. So if we put n, let's say up till n. So if we put n, this is 2n plus 1, and at the place of r, if we put n, so what we are getting? We are getting 1 plus 1 by 2 up till, we can write at the place of r, we can write n. So this is 1 by n we can write. Correct? Now, in this is the required sum. So now in this, if we take 1 from here, 1 from here, and 1 from here, and 1 from here. So what we are getting, if we are writing 1, then this is 3 plus 5 plus 7, then it will be 9, and it will going till 2n plus 1, right? The second term, if we take 1 by 2, so this is what we are getting, 1 by 2 into 5, then here we are getting 1 by 2 into 7, then in next term we will be getting 9, then 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, like this. So 1 by 2 into 9. So if we take 1 by 2, so what we are getting? We are getting, it is that sum is starting from 5, then 7, then 9 till 2n plus 1. Correct? Now, this sequence, if we keep on writing, then if we take 1 by n outside, what we are going to get, that last term we are getting is 2n plus 1, because this 2n plus 1 is going to multiply with 1 by n. So in this, if we see, there are n terms. In this, there are, we can say, n minus 1 terms. In the next, if we write that 1 by 3 times, this all plus 1 by 3 times, it will start from 7. So 7 plus 9 plus 11 up to 2n plus 1. So we can say in this, there are n minus 2 terms, and at the end we are having only one term, that is 2n plus 1. It is going like this. So we can clearly see from here that this is an AP with n terms. So we can write the summation of this AP. Similarly, this is another AP, that first term is 5 and total number of terms are n minus 1. This required sum we can write as 1 into sum of this AP. Total terms n. So let's say n by 2. First term is 4, last term is 2n plus 1. So 2n plus 1 plus 3 is 2n plus 4. Then 1 by 2 times this AP, if we write. So first term is 5, and total number of terms is n minus 1 by 2 we can write. Then first term is 5, last term is 2n plus 1. So their sum is 2n plus 1 plus 5. So that is 2n plus 6. like this, if we keep on writing, let's say write one more. So that is 1 by 3. Number of terms are now n minus 2 divided by 2. Sum of AP first term plus last term, that is 2n plus 8. If we keep on writing, last term is 1 by n into 2n plus. Now if we simplify this required sum we can write 1 multiplied by, that is n by 2, and this is 2 times of n plus 4. So we can write this as n into n plus 2. Now this we can write 1 by 2 times. This 2 we can cancel with 2n plus 6. So we can write n minus 1 into n plus 3. Now this will be 1 by 3 n minus 2, and this will be n plus, we can write n plus 4, and up to we can write 1 by n 2n plus 1. So this we can write, the general term for this we can write, let's say 1 by r n minus r plus 1 into n plus r plus 1. So if we put r value 1, this is 1, r value 1, this is n, this will become n, r value 1, this will become n plus 2. If we put r value n, so this will be cancelled. If we put r value n, so this will become n, this will become n, and n cancel, so we are getting 1. N plus n is 2n plus 1, so we are getting this term also. Suppose if we are putting r value 2, so if we are putting r value 2, this is n minus 2 plus 1, that is n minus 1, and n plus 2 plus 1, that is n plus 3, and this is 1 by 2, so we are getting this term. So now we can clearly say that this is required sum is summation over 1 by r, this we can write n plus 1 whole square minus r square, where r is varying from 1 to n. Okay, now this we can write n plus 1 whole square by r minus r, this summation, r is varying from 1 to n, correct? Now this n plus 1 whole square we can take outside, and this summation over 1 by r is varying from 1 to n, is nothing but it is given that this is f of r. So if it is going from 1 to n, we can write this sum, we can write as g of n. Okay, so summation over 1 by r, where r is varying from 1 to n, we can write g of n. And we have to express this required sum into terms of Pn into g of n plus 1 minus Qn. Okay, so now this summation we can write as g of n minus summation over r. Okay, so this is minus of summation over r, where r is varying from 1 to n. So this you can write n plus 1 whole square g of n minus n into n plus 1 by 2, correct? Now, but what they're asking that required sum, we have to write p of n into g of n plus 1 minus q of n. So, and we are getting here g of n, right? So, g of n we know. What is g of n? G of n is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n. So if we wish to write g of n plus 1, we can write this as 1 plus 1 by 2, 1 by 3, 1 by 4 up to 1 by n plus 1 by n plus 1. So this is g of n. So g of n we can replace as g of n plus 1 minus of 1 by n plus 1. So this we are getting n plus 1 whole square. G of n we are replacing g of n plus 1 minus 1 by n plus 1 minus of n into n plus 1 by 2. So this is we can write n plus 1 whole square g of n plus 1 minus of this n plus 1 whole square multiplied with the minus of n plus 1. We can write n plus 1 minus of n into n plus 1 by 2. So this we can clearly say now we have required sum in this form, n plus 1 whole square, that is Pn into g of n plus 1 minus this we have to simplify. So we can simplify this. Let's take minus of n plus 1 common. So what we are getting here, we are getting 1 plus of n by 2, that is we can write from here n plus 1 whole square. Now this is Pn g of n plus 1 as it is minus of n plus 1 into n plus 2 by 2. So required sum is in the form of P of n into g of n plus 1 minus of q of n. So from here clearly we can say that P of n is n plus 1 whole square, q of n is n plus 1 into n plus 2. So now we can solve what they are asking. They are asking r is varying from 0 to 9 p of r. Okay, so that if r is varying from 0 to 9 p of r, that is r plus 1 whole square. So we can write, if we put r equal to 0, we are getting 1 square, then 2 square, up to when r value 9, this is 10 square. This is sum of the squares of first 10 naturals. So that is n into 2n plus 1, that is n into n plus 1. So let's say 11, then 2n plus 1, it is 21 whole divided by 6. This summation we are using basically, n into n plus 1 and 2n plus 1 by 6 if we put n value 10. So this we can solve. This is 7, this is 3, this is 2, and this is 5. So what we are getting is 35 into 11. 35 into 11 is 385. So this is the value. Now another part, what they're asking P of 13 minus Q of 13. So P of 13, so P of 13 is basically 13 plus 1 whole square, that is 196. Q of 13 is 13 plus 1 and 13 plus 2, that is 14 into 15. So that is n by 2. Q of n is n plus 1 into n plus 1 by 2. So this divide by 2. Okay, this is Q of n, this full. So n into n plus 1 by 2. Okay, so this value is 7 into 15, that is 105. So what they're asking is P13 minus Q13, that is 196 minus 105, that is 95.